All right, second part of division, or second part of section 6.2 is all division. And with the division, there's basically two different types we're going to do. And the first type we're going to do is we're going to divide and simplify. Okay, and even in this first type we're going to do, there's a couple of different variations of things we're going to do. But for the most part, it's just going to be that. We're going to be dividing and simplifying as we're going through with these. All right, so first thing we're going to do, go through the steps here. You want to divide the radicands. And if you have forgotten over the last couple of days when we're talking about what we're talking about, the index is going to be the number that's right here on the outside of the square root. The radicand, that's going to be the number that's on the inside, or the variable that's on the inside. So first step we're going to do is we're going to divide the radicands. Step 2, if you have variables, because it's going to be, I think, about a 50-50. You'll have some with variables, some you won't. So if you have variables, subtract the exponents. And then step 3, at the very end, once you've done the division, you've subtracted the exponents and everything you can do there. At the end, you may have a little bit of simplifying that you may have to do then. So if there's anything left to do, just go ahead and simplify more if it's possible. Now, at that point at the end, it may be that you might have to take and break down the square root or the third root or whatever the number is. So it's basically just that you're still factoring this thing out as much as you possibly can when we're going through these. Okay, so here's what we're going to do. So there's our 3 steps for everything we're going to do. All right, first problem. Let's stick with square roots because it seems like it's a little bit easier to work with square roots than third, fourth, and fifth roots. So we start with square root of 200 over 2. And if you've got it written as 2 separate problems, you can basically think about it as one big fraction. And what is 200 divided by 2? It's 100, right? Okay, and now what is the square root of 100? It's 10. There you go. So a lot of the problems that you're going to do when you get finished with it, you're going to have a perfect square root at the end. Now we'll look at one here in a minute where it's not a perfect square root. But for right now, we'll look at a couple of them where we come out to get just perfect square roots off of these. Okay, let's give you one with the third root, because sometimes we go third and fourth root. It makes things a little bit more difficult. So we have the third root of 81 over the third root of 3. And when they give it to you as 2 separate fractions, you can really think about it as one fraction. So it's really 81 divided by 3. And if you check that, that is 27. And what we said yesterday was is that you can also, on these problems, sometimes you can just use your calculator to see if it will simplify. And if you did check the third root of 27, and if you weren't here yesterday, let's show you that real quick. If you have something other than square roots, if you need to check it for these calculators, whatever the index is, you put the index first, hit 3, and then you're going to hit second, and then hit what looks like a rooftop or an arrow button right here. If you hit that, it gives you the X that's in the index, so it tells you that 3 is your index, and now you can actually put in the number of 27, and the answer is going to be 3. And we'll show you in a minute what to do if that's not a perfect number. If it doesn't come out to be a whole number, we'll show you what we'll have to do just to break it down. So for this one, let's go third root of 250. X to the 7th and y to the 3rd. Let's put that over third root of 2x squared y. Now, and you can do this one a couple of different ways. You can think about it as one number at a time. So that would be 250 over 2. Third root of that one. And if you want to do the x's one at a time, and then the y's by itself, you can almost do these like it's each individual piece. So it's the third root of, and then just look at the x's. It's x to the 7th over x squared. And then for the y's, it's the third root of y3 over y. And the only thing you might want to do is when you have a variable that's by itself, you may want to go back and put a 1 on the exponent just so that you don't forget that when we start subtracting these, that you have to do 3 minus 1. Okay, if we do 250 divided by 2, that is 125. And on the exponents, again, you're just going to subtract these, so that's the third root of x to the 5th. For this one, that's going to be the third root of y squared. Okay. And if you check third root of 125, that does come out to be perfectly, because if you'd taken 125 and break it down, that would have been 5 times 25. 25 would be 5 times 5. So you would have the third root of 5 to the 3rd. Those would cancel. And just make that 5. Alright, for the people that were not here yesterday, or maybe that was Monday. Actually, yeah, we did both of them the last couple of days. When you're simplifying the exponents with the variables, you're going to take the outside index and divide it into the power on the inside. So 3 going to 5 one time, with 2 left over. And then for the y's, we're going to take 3 and divide it into 2. And somebody's probably saying, well, 3 won't go into 2. That is absolutely correct. It will not go. So we're going to have 2 left over. So on the outside, we're going to have 5. And remember, when you divide these numbers, this is going to tell you the exponents that go on the outside. This is going to tell you the exponents you have left on the inside. So for the x variable, we're going to have 1x on the outside. We're not going to have any y's. And then on the inside, you're going to have 2 x's and 2 y's. So as you go through the problem on these with division, and we basically did the same thing with multiplication yesterday. Just do it one piece at a time, that you're going to do just the numbers, one variable, in this case the x's, then you do the y's, and just work it one piece at a time, and then come back at the end and put it all back together. Alright, let's get you one more here. Because all these so far, the numbers have come out to be perfect numbers. Let's get you one where the numbers don't come out to be exactly perfect, where we've got to work on just a little bit. Yep, so let's go with square root of 400 over square root of 2. Okay, and again, if you take 400 divided by 2, it's 200. And if you check 200, it is not a perfect square root. So that one, we've got to break it down. When we start to break the 200 and break it down, again, you may be saying, what does it look like that's not a perfect square root? Well, You get a decimal answer, and if it's a decimal answer, that means it's not a perfect square root. You cannot give me decimal answers on the test. Everything either has to be a whole number or a square root or a cube root or whatever the root happens to be. So for 200, we start to break it down. It's 2 times 100, which is 2 times 50, which is 2 times 25, which is 5 times 5. We've got 1, 2, 3 2s, and then 2 5s. And as long as we're doing square roots in this problem, everything's in pairs. So there's a pair of 2s, so that 2 will come out. There's a pair of 5s, so that 5 will come out. And that 1 2 that's here stays on the inside because there's 3 2s, so we can take a pair out and there's 1 left over. So then on the outside it's 2 times 5 or 10 square root 2. So not every answer is going to be a perfect square root when you do the square roots. Some will be perfect, some will not. It just depends on the numbers and exactly how they match up as we go through these. Okay, so that's the first type we're looking at, where you just take the fractions you have, you simplify the fractions as much as you can. If you have variables, you subtract the variables, and then once you get to the end, you break down the variables to figure out how much goes inside, how much goes outside. So that part of it's the same thing we were doing yesterday when we were doing the simplifying on that part. Here's where we're going to change gears on this one and do kind of a different thing. And this will, we're going to do one part of it today. We're going to also come back and do another part with this second thing tomorrow. But the type 2 is where they're going to ask you to rationalize the denominator. And what rationalize means in this case is, that means you just have to eliminate the radical from the denominator. And there's basically 2 parts on this one that we're going to do. And just so we can kind of get an idea of what this will look like. It may be that you get a problem where it's something like this, where it's 4 over the square root of 3. That there's no other square root up here, so there's nothing you can do to simplify a fraction. You know, even if it was, we'll do one in a minute where we've got 2 different square roots, so you can see that there's no way you can simplify this one. But again, for this kind of problem, they're going to tell you to rationalize it. And basically for this one, if it's square roots, they have a little shortcut we get to do. That you're going to multiply the fraction. And when we say multiply the fraction, that means both numerator and denominator by the radical in the denominator. Or of the denominator, whichever way we can say it there. Okay, so here's what we're going to do. We're going to take the original problem that we had, 4 square root of 3, and we're going to multiply it by, well, the part that's the radical that's in the denominator, that's going to be square root of 3. So we need to multiply the top and the bottom by square root of 3. Alright, now it's going to do 2 things. Number 1, on the top, there's nothing you can do with the top on this one. If you do 4 times square root of 3, well, it's just that. It's 4 square root of 3. On the bottom, though, what is the square root of 3 times the square root of 3? 3 times 3 is 9, because that's what we were doing yesterday when we were multiplying the parts together, that all you have to do is just multiply these two numbers together. But what is the square root of 9?
3.
Just 3. Okay, so that's 4 square root of 3 over 3, and that would be the final answer that we're looking for. Now, again, when you're rationalizing the denominator, they really don't care how complex the numerator is. That's not the issue. The whole thing with rationalizing is that you want the bottom part to be just a number. That way, if you have to add and subtract these kind of fractions, if you can rewrite it where it's a whole number in the bottom, it's a lot easier to find common denominators with whole numbers than it is if you have radicals in there. So that's the reason why you do that for this part of it. Is that if you're going to add and subtract fractions, it's a lot easier to find common denominators with fractions than it is with whole numbers than it is with radicals. All right, so for this one, let's give you one where you've got two radicals. We've got square root of 5 over square root of 6. And now here's where some people may get confused with the first. Now again, here's the big thing in this one, is they're going to tell you to rationalize. So for this part of it, they're not going to make this confusing where we were simplifying on the first part. That for this one, there's nothing you can do to simplify 5 over 6. If that was just a fraction by itself, there's nothing you can do. So it says to rationalize, so that means we're going to take both of these parts and multiply it by square root of 6. All right, and on the top, 5 times 6 is 30. On the bottom, 6 times 6 is 36. But every single time when you do this, that bottom number now should be a perfect square root. If you take the square root of 36, that's just 6. And you've got square root of 30 over 6. Now, and somebody's probably thinking, but hey, you can take 30 and break it down. Yes, you can. But if we did take 30 and break it down, we'll do that on a scrap piece of paper here real quick. That if you took 30 and we're breaking it down, if you're worried about that, what about the 30? If you take 30 and break it down, if you do it as 2 times 15, 15 would be 3 times 5. Square root of 30 is 2 times 3 times 5. No pairs of anything, correct? And if there aren't any pairs, you don't have anything you can simplify. So 30 is one of those numbers that, yeah, it looks like it should be able to be broken down, but 30 in square root form cannot be broken down to be anything simpler. So for that one, we're just going to leave it as square root of 30 over 6. Okay, one or two more of these and we'll show you what the other part we're going to do here. All right, let's go with 10 over the square root of 15. Okay, and again, this one, 10's on the outside of the square root because it's just a whole number. That one's a radical, so don't try to simplify this one because that's a whole number and that's a square root. If you're going to simplify, they both have to be square roots, so they both have to be whole numbers. So for this one, we're going to multiply the top and the bottom by square root of 15. Okay, now, and if you didn't catch it on the first one or the second one, here's what we want you to catch when you're doing these. If you multiply by the same number here, like this one, we had 6 times 6 to get 36. Once you take square root of 36, you're going to get this number back. So this one, we could do 15 times 15 and make it 225. But when we square root the 225, you're just going to get this 15 back. So let's just save one step and let's just put that as 15. And that'll happen every single time. That if you do the same number times itself, and then you square root it, you're going to get that number back without the square root. So same thing here. We can do 15 times 15 and make it 225. But when you square root 225, that's just going to get you back to 15. Okay, and for this part, once you get here, if that square root of 15 wasn't there, if it was just 10 over 15, you can divide them both by 5. So for this one, you can go one more step and simplify this one. Divide both of these by 5 and make it 2 square root of 15 over 3. One more of those, and then we got one other small change we've got to make, and then that'll be the last thing we're looking at here. Still rationalizing. All right, so for example 4, square root of 6 over square root of 12. And for this one, you can do it two different ways. We'll show you one way and then show you what would happen. Can you simplify 6 over 12? Absolutely, right? You can divide them both by 2, you can divide them both by 3, or you can divide them both by 6, right? So if you see a fraction that you're working with and they're both in the square roots, just go ahead and divide them both by whatever you can factor out, just like it was a regular fraction. Divide them both by 6, you're going to make that square root of 1 over square root of 2. But what's the square root of 1? It's just 1, right? Yeah. So really that's 1 over square root of 2. So this is really the number we need to rationalize. That we've got 1 over square root of 2, now let's rationalize that thing. Okay, so the next thing we would do is we would multiply, let's just put it down here. We've got 1 over the square root of 2. We're going to multiply it by square root of 2 over square root of 2. And on the top part, if you do 1 times the square root of 2, that's just square root of 2. And again, for this one, on the bottom, we could do 2 times 2 and make it 4, but if we square root 4, it's going to be just a plain 2. And if somebody's asking, why can't we simplify that farther like we did back here? Well, this one's inside the square root, this one is not. And if one's inside the square root and one's not, there's nothing you can do to simplify that part. They either both have to be in the square roots, or it could be like this one where they're both on the outside of the square roots, and then you could simplify the 10 over 15. Or we divided this one by 5 and divided that by 5. So they either both have to be inside the square root, or they both have to be on the outside of the square root to simplify. Okay, now in this part, you don't necessarily have to write this one down, but let me just show you what would happen here. Just kind of a what if here. Because I know there's somebody's probably thinking, well, what if I had missed that 6 over 12 and I didn't catch that would simplify, which could happen. So you don't have to write this down. You just kind of watch it and see. If you just said, all right, I'm just going to multiply by square root of 12. Okay, 6 times 12 is 72. 12 times 12 would be 144. When we square root it, it's just going to get you back to a regular 12. That's where you're going to have to take this square root of 72 and start to break it down. So it's 2 times 36. And then hopefully you do this when you go, oh, well, 36 is a perfect square root. I can take that 36 out and make it 6 square root of 2. So then you would have 6 square root of 2 over 12. Well, now that you've got 6 over 12, you can divide this one by 6, you can divide this one by 6, and then you wind up getting square root of 2 over 2. So you can get the same answer, but look to see if you can simplify first, because it makes the numbers a lot easier to work with. If you don't realize you could simplify, you'll get the same answer. You just got a lot more work you've got to do to get there. So if you can see something you can simplify first, absolutely go ahead and simplify that part of it first, because that will save you a lot of work when you're going through this. All right, and then the last little thing we're going to throw at you, still under rationalizing, is everything we did here was square roots. The last thing we're going to look at is, all right, what happens if it's not square roots? If the index is bigger than 2, a little bit different setup on this one. Because if the index is bigger than 2, then what you have to do you have to multiply by radicand with a power so that the index and power of the denominator are the same. Again, this is still going to ask you to rationalize. And if it was square roots, we just multiply by whatever the square root was. If it was square root of 6, you multiply by square root of 6. If it was square root of 93, you just multiply by square root of 93. This one's a little bit different because now we're doing third roots and fourth roots and fifth roots. They may even throw out 6, 7, 8 roots on this one just because of the things you have to do here. All right, if you're looking at that, if you're going, okay, I'm kind of lost there. Basically, let's give you sometimes the pictures speak a lot more than the words. So let's give you one where we actually look at an example here. All right, let's do 10 over the 7th root of x squared. Okay, so you want the shortcut version on what to do here? If not, I'll tell you, we can do it the long way. You want the shortcut version? Yeah. All right, here's what you're going to do. Subtract those two numbers. Just subtract the index and the power. What's 7 minus 2? That's 5. There you go. So that's 10. So here's what we're going to do. We're going to take the original problem. And when you subtract these two numbers, that tells you what power of x you have to multiply by. So now we're going to multiply by the 7th root of x to the 5th. And that's the number you're going to multiply the top and the bottom by down here. Okay, and kind of like the other problems, there's really not much you can do on the top part. It's going to be 10 times the 7th root of x to the 5th, nothing there. But on the bottom part, if you've got 2 x's over here, 5 x's over here. Well, if you've got 2 x's and 5 x's, that's 7 x's, right? And what we've said the last couple of days is that if that power matches this index, they cancel each other out and leaves with just the x by itself. And again, if it asks you to rationalize, that's all you're trying to do is make it so that the denominator doesn't have any kind of power or any kind of radical in it. Alright, so let's do 2 more of those. Alright, let's say this was 4 over the 9th root of b to the 3rd. Okay, and again, all you're going to do is you're going to subtract the index and the power. 9 minus 3 is 6. So we're going to take the original problem and multiply it by 9d3. All right, and the top part. Again, not really much you can do with the top part because it's pretty much just going to be that thing. And then on the bottom, well, again, if you put these two together, that's going to be 9b to the 9. But if we do that, that should cancel, and it should be just b. Good. Now, let me show you one more, because with variables, most of the time we do a couple of those. If we do 2 or 3 of those, people go, okay, I'm getting the hang of it, because all I'm going to do is just subtract these two numbers. And basically, when I subtract these two numbers, that power is going to go up here. And on the bottom, I'm going to have just that letter by itself. There's not going to be any square roots or third roots or fifth roots with it. And that's pretty much going to be it. This is one, it works the same way, but because it's numbers, it looks a little bit different. Let's do the fourth root of 5. We're going to put that over the fourth root of 7. Sometimes people get to this one and they go, okay, what do we do here? Still going to do the same thing. You're still going to subtract the exponents. And people go, well, 7 doesn't have an exponent. Well, if it doesn't have an exponent, what's it understood to be? Because how many 7s are right there? Just have 1, right? Yeah. Well, right now there's 1, but we're going to need 3 more. So now we're going to do 4 minus 1. So we're going to multiply by the fourth root of 7 to the third. So we got 1. So we do 4 minus 1. Now we've got the 3 more that we need. Okay, and on the top part, just multiply together. It's the fourth root of 5 times 7 to the third. On the bottom, that's the fourth root of. And again, if you do 7 to the first and 7 to the third, that's 7 to the fourth. And the whole reason we do that is if you've got the index and the power the same, they cancel each other out, and that's just 4. Now, the good thing about the top part is, if you do this one, just multiply all this stuff together, and whatever that number is, that's going to be the answer. It won't break down. So that's one where we're going to just use a calculator. So we're going to do 5 times 7 to the third power. Not that you can see that there. But there we go. So just multiply that part out. That is 1,715, and do not try to break that big a number down. Just leave it just like that. Okay, so if it's a square root, they ask you to rationalize it. It's pretty simple. You just multiply by whatever that number is that's in the denominator that's the square root of. If it's something bigger than 2 for your root, if it's 3, 4, 5, if it's 9, if it's 10, if it's whatever, you just got to subtract these two exponents and multiply by that number. And again, whatever you have the square root of on the bottom, that's not 4. Sorry, that's supposed to be a 7. The 4's cancel to give you a 7. My bad. Because the 4th power, 4th index cancels, so now we've got that to be a 7. Sorry about that.